Hello, and welcome to our webinar, Datavail Accelerates AWS Adoption for Sony DADC New Media Solutions. My name is Lou Delatorre. I'm a solutions architect with AWS, and today I will be your host and moderator for the webinar. I'm also joined by Siva Kumar of Datavail, as well as Blaine Baker of Sony DADC New Media Solutions. And we're very excited to have you here with us today. By the end of the webinar, we hope to show you how Datavail, an AWS partner, helps Sony DADC New Media Solutions accelerate their adoption of the AWS cloud, thus taking their business to the next level. As you may know, Amazon Web Services is a cloud computing platform that is optimized for Windows-based workloads. AWS provides a range of scalable services that align to ever-changing business needs. Now, one of those services is Amazon EC2, or Elastic Compute Cloud, which is our virtual machine offering on AWS. AWS has been running Windows on EC2 since 2008, and over the last decade, AWS has continued to support the various Windows operating systems that Microsoft has released, as well as the various Microsoft product offerings, such as Microsoft SQL Server. As a result, many customers have migrated their Windows workloads to AWS. Why are customers migrating their Microsoft workloads to the cloud? Well, there are many reasons, but I'd like to highlight three key reasons. First, the cloud reduces the burden on IT staff. And that's because AWS takes the heavy lifting, such as hardware procurement, deployment, and maintenance of their hardware off of the customer's shoulders and places it on AWS, thus allowing the IT teams to focus on innovation and adding business value. Second, the cloud enables more rapid scalability. What used to take weeks to months now takes minutes to hours. And third, the cloud lowers costs because of the benefits that come from the economies of scale. The more customers that adopt the AWS cloud, the lower we're able to reduce costs. So those are some key reasons why customers migrate their workloads to AWS, but there are many other benefits that customers receive when they migrate their Windows workloads to AWS or deploy net new Windows workloads on AWS. For instance, the pace of innovation is accelerated. Costs are reduced because of the economies of scale. Their security posture is strengthened. Availability and performance are improved. Manageability and scalability become easier in the AWS cloud. Let's dive deeper into each of these and explain why that is the case, starting with the pace of innovation. Because of the AWS pace of innovation, customers have access to the broadest and deepest set of cloud services enabled by AWS. Last year alone, 1,017 new services and major features were introduced. It'll be interesting to see how many are introduced this year after reInvent, which is our annual conference taking place at the end of November in Las Vegas. Also, the fact that customers can provision resources on demand and eliminate lengthy procurement and deployment cycles accelerates innovation. By migrating to the AWS cloud, customers can establish a global footprint within minutes without the cost or time associated with building new data centers. Also, customers can integrate technologies like IoT and machine learning with less risk. If it doesn't work, then the customer can shut it down, or if it doesn't meet their goals and objectives, they can move on to the next idea. And no huge loss is incurred because minimal investments are made, thus allowing customers to experiment more and innovate faster. Because of the cloud, you can now also focus on delivering customer value instead of time-consuming hardware maintenance, such as patching and hardware refreshes. All of this accelerating the pace of innovation. Typically, having access to such a broad and deep set of services that helps accelerate innovation results in greater costs. However, with AWS, most customers are actually able to reduce their cost. And that's because at AWS, you only pay for what you need, and you replace CapEx with OpEx. You can also bring your existing investments, such as Microsoft licenses, to AWS, and we'll talk about that a little bit more later. You continue to derive value from whatever investments you made as part of your hybrid architecture. For instance, if you've invested in vSphere or System Center or any other third-party solution to manage and support your on-premises infrastructure, you can continue to use them to manage and support your Amazon EC2 resources. To further reduce costs, you can use Amazon EC2 reserved instances and potentially save up to 70% of the on-demand prices. Also, finally, you can improve application performance without the hardware refresh costs. If you want to take advantage of newer instance type or a different instance family, it's a matter of just a few clicks. So as you can see, the AWS cloud is very cost effective. It can help you significantly reduce costs, but is still quite extensive in its functionality. Now at AWS, we understand that for most organizations, security is their chief concern associated with moving workloads to the cloud. So at AWS, security is our #1 priority. As such, we take a multi-layered approach to security that includes physical, operational, and technical protocols. For example, the AWS infrastructure is optimized for compliance regulations across a multitude of industries, meeting more than 50 common regulatory requirements using AWS assurance programs. AWS enables users to secure their AWS environment through isolation. Amazon Virtual Private Cloud, or VPC, allows you to create private subnets, isolating your infrastructure within the AWS cloud. To connect to a VPC, users can leverage a traditional VPN, or they can utilize AWS Direct Connect for a private dedicated network connection between their data center and AWS. Additionally, the AWS Identity and Access Management Service integrates with Microsoft Active Directory, providing fine-grained access controls for your AWS resources. Finally, you can improve application performance without the hardware refresh costs. If you want to take advantage of newer instance types or a different instance family, it's just a matter of a few clicks. So as you can see, the AWS cloud is very cost effective, can help you significantly reduce costs, but is still quite extensive in its functionality. And data stored in the AWS cloud is also protected by 256-bit encryption, both while in transfer and at rest. AWS CloudTrail logs keep track of your API call history, providing visibility into who has requested access to what, when they requested it, and the response elements returned by AWS, all ensuring that the users that are accessing AWS are the ones that are supposed to access it. And these logs can also be stored safely in the cloud, enabling compliance audits and internal security analysis at a moment's notice. There's also third-party security solutions that are available in our AWS marketplace that customers can choose from. Now, Amazon EC2 offers a 99.95% SLA, and most of our customers experience significantly less downtime than with their on-premises environments. This reliability is grounded in our proven experience building enterprise-scale data center infrastructure. Our experience has also allowed us to build an agile, high-performing cloud platform. Customers can leverage multiple availability zones within a region to make their application highly available. They can choose from a variety of Amazon EC2 instance types, each designed with different configurations of compute, storage, memory, and networking capacity to support the needs of their target workloads. Their applications and EC2 instances can automatically respond to changing resource requirements using auto-scaling and elastic load balancing. all while maintaining full visibility into their service health, performance, and availability from a single pane of glass. And to further improve performance, customers can place applications and data in AWS regions near end users to reduce latency. But all this performance really wouldn't mean much unless it could be easily configured and delivered, which is why AWS has designed their cloud platform to feel familiar to Windows IT pros who are used to on-premises environments. So customers can continue to leverage their existing investments and tool sets such as PowerShell, System Center, vCenter, so that they can manage their AWS resources just the same as they were doing when managing their on-premises resources. Also for developers, they can continue to leverage tools like Visual Studio, TFS, Jenkins, and other tools for development as well as DevOps, thus reducing the learning curve. And customers can leverage auto-scaling, elastic load balancing, and other features to automate and to scale quickly and thus free up more time for innovation and delivering customer value. AWS also offers managed services such as Amazon RDS, Relational Database Service, which offloads Microsoft SQL Server administrative tasks such as managing the instance, the operating system, or database patching, taking that off the customer's shoulders and allowing them to focus on database optimization and schema tuning for their applications. Additionally, the AWS Partner Network consists of partners like Datavail that can help with migrations to AWS, as well as offer managed service offerings. You can rest assured that you will continue to receive the same support from Microsoft for your Microsoft workloads on AWS as you do on premises. So those are some of the key benefits that you receive from migrating your workloads to AWS. Now, a common question that typically comes up when we're talking about running Microsoft on AWS is around licensing. What are my licensing options on AWS? Well, as you probably know, with Microsoft products, you can literally spend hours talking about licensing. But when you boil it all down, it comes down to two options: license included or bring your own licenses, BYOL. With license included, the cost of the license is included in the AWS bill, along with the cost of the compute and the storage. In this case, AWS handles license compliance. This applies to both current and legacy versions of Microsoft products available in the AWS Marketplace or via the AWS Management Console. Now with BYOL, you can bring your own license. You can use license mobility through software assurance on our default tenancy. Or if you don't have software assurance, you can make use of our Amazon EC2 dedicated infrastructure and still bring your own licenses. The benefits here are that you're able to extend your existing license investments to the cloud and pay only for the AWS services that you consume. However, one thing to keep in mind is that you are responsible for license compliance in this case because you're bringing your own licenses. Therefore, you have to make sure that you are compliant. Now, the last thing I'd like to talk about is some help that we offer to customers to help them accelerate their migrations or net new Windows deployments on AWS. And we do this by means of a program that we created. It's called the Rethink for Windows program. Now, this program is designed to help customers who want to migrate or build significant Windows Server, SQL Server, and .NET workloads on AWS. And with this program, a percentage of the customer's annual run rate can be offered as a credit. And the annual run rate should be reached within 24 months. Through a qualified Amazon partner such as Datavail, customers may also get further migration assistance. So this is a limited time credit program. So please contact us today to see if your window workloads qualify for this so you can take advantage of this opportunity. With that, I'd like to now turn your attention over to Siva Kumar, who will be talking to you about migrating Microsoft SQL Server workloads to the AWS cloud.
Thank you, Lou. Hi, everyone. This is Siva Kumar from Datavail. Thanks, Lou, for talking about the advantages of AWS and the benefits of running Microsoft SQL Server workloads on AWS Cloud. I also have Blaine Baker from Sony DADC New Media Solutions. Blaine Baker is a manager of app support and BI at Sony DADC. Datavail is one of the largest remote database administration companies in North America. And at Datavail, we provide project services, which includes health checks and assessments, database upgrades, database migration, and as part of operational managed services, we provide 24/7 monitoring, and we also provide monitoring and incident responses. As part of proactive services, we provide health checks and also performance tuning. We also do data development services, performance tuning, automation, data warehouse, and also optimization of the code. I have been with Datavail for the past 9 years, and my areas of specialization includes database performance tuning, database scalability, mostly solving isolation and concurrency problems. I'm also involved in migrating the on-prem database environment to cloud and also config and DR in AWS Cloud.
Sony DADC New Media Solutions is an industry leader in the digital supply chain. In 2017, we went all in with AWS and have just delivered our 10 millionth asset. We have over 1.2 million hours of premium entertainment content coming from over 450 distinct content owners. Venue is our content management, distribution, and OTT solution, leveraging integrated commerce solutions to bring an end-to-end service suite to our partners and their clients. My name is Blaine Baker, and I'm the manager of the Business Intelligence and Reporting team for New Media Solutions. I have 9 years of experience providing technology expertise to the media and entertainment industry and worked in the public sector prior to that. I've been with New Media Solutions since 2011. I perform the database architecture role and engage with Datavail for the day-to-day care and feeding of our database infrastructure. Some time ago, our primary DBA left the company to pursue other opportunities. Senior technology leadership for New Media Solutions consulted with key technologists and other Sony business units, inquiring about their experiences with database administration service providers. We were also looking for a partner with an established track record of migrating on-premise database infrastructure to AWS specifically. Datavail came highly recommended through another Sony business unit, and we brought them on board to manage the day-to-day care and feeding of our on-premise database infrastructure. When the time came to perform the migration to AWS, Datavail was a natural choice given their familiarity with our existing environment and expertise in cloud migrations. Prior to our cloud migration, our on-premise infrastructure was designed for handling the volume during the busiest times of year for our clients. The problem with this approach was that the systems remained underutilized for the rest of the year. One of our primary goals in migrating to a cloud infrastructure was to minimize our costs during those low volume periods and scale out our application server footprint painlessly during anticipated periods of high volume. The timing for the migration was driven by our contract renewal with our traditional hosted data center and for our capacity to migrate a 20 petabyte archive of content from our LTO tape library to our chosen cloud platform. During our evaluation process, we investigated a number of possible cloud vendors to choose from. We determined that only AWS could provide the storage and throughput capacity required by both our platform and our archive migration timeline, while at the same time satisfying our cost reduction drivers. Hopefully at this point you're able to put yourself in my shoes and understand the challenges and desired outcomes from the business perspective. Since you joined us today, you likely have your own specific challenges in mind and are interested in how we accomplish this migration together with Datavail. At this point, I'd like to turn the presentation back over to Siva to dive into the technical details. Siva?
Thank you, Blaine. I'm going to start talking about the on-prem database platform overview of Sony DADC NMS, and also going to start talking about some of the challenges that Sony was facing. And then I'm going to talk about the approach we took, and I'm going to talk about the performance baseline which played a very critical part in our approach. And then I'm going to talk about the proposed architecture and the post-migration activities. On-premises database platform overview. This database environment had SQL Server 2008 R2 Enterprise Edition running on Windows Server 2012 Data Center Edition. This was running on an active passive 2-node cluster, and we also had a standalone server which was being used for reporting and data warehousing purposes. The standalone server was serving a real-time dashboard application through SQL Server reporting services, and this was essentially very critical for the business. There was an ETL process that was configured between the OLTP production server and the data warehouse server. We were using change data capture and SQL Server transaction replication for doing the ETL process. We also had stage and test and dev environments in this database platform. As far as the hardware goes, the active passive node was running on a 32 CPU core machine with 256 GB of RAM. And as far as the total amount of the data goes in terms of the database, there was 10 terabytes of total data, and the biggest database size was 1 terabytes. And as far as the storage goes, we were using solid state drives for the primary user databases, and the TempDB TempDB was placed on SSDs as well. The magnetic disks were used for the secondary databases. This is the schematic of the existing architecture, and as you can see, the client application connects to the Windows failover cluster through a SQL Server virtual name, and the Windows failover cluster consisted of an active and a passive node. The active node takes all the read and write transactions, and the passive node, as the name states, it's passive until it becomes active. That happens when you do a failover. The failover is automatic, and whenever the active node goes down, the failover automatically happens to the passive node. You can also see there is an ETL process configured between the OLTP production server to the data warehousing and reporting server. This ETL process was using change data capture and SQL Server transaction replication for replicating the data from the active node to the data warehousing and reporting server. On top of the data warehousing and the reporting server, SSRS was running, and which was serving the client application dashboard, which was very critical for the business. One of the primary requirements for the dashboard report was to access the more or less real-time data. However, in our case, the ETL process was asynchronous, and we were trying to keep the latency as low as possible. You can also see the active and the passive nodes are connected to a SAN, and that's where all the databases are stored. We were also using the local storage in our case, which is a SAN, for storing the backups, and all the older backups were shipped to off-site for tape storage. This was primarily used for DR purposes. Database migration. As far as the database migration goes, the biggest two questions we had was what kind of instance we have to choose in the AWS. Are we going to choose RDS in AWS or SQL Server running on EC2? The second biggest question we had was how are we going to migrate 10 terabytes of data from on-prem to AWS? So going back to the first question, we decided to go with SQL Server running on EC2 because the application had was heavily dependent on Microsoft SQL Server native features like linked server, common language runtime, and also some SQL Server jobs. And as far as migrating the data from on-prem to AWS, we were not able to use the Amazon database migration services because of the current network configuration we had on the on-prem environment. The action we took was we decided to migrate the active passive Windows failover cluster from on-prem to Amazon EC2 instances running on different AZs in a region. We also decided to upgrade the SQL Server 2008 R2 to the most recent version, which is SQL Server 2014. The results were pretty good, and we were no longer using the extended supported model of SQL Server. We were also able to leverage the always-on availability groups together with the AWS architecture. Challenges. The customer, Sony DADC and MS, they had three main challenges. The first challenge was the cost reduction. Second challenge was incorporating HA and DR into the architecture. The third challenge was solving the reporting latency problem and also solving some of the issues related to the transaction replication. I'm going to talk about each of these in the upcoming slides. Cost reduction. The main driver for the AWS migration was to reduce the costs. One of the actions that Sony took was outside the database layer, they were able to choose the right-sized Amazon EC2 instances for their application servers and for other servers, and they were also taking advantage of the spot instances, and they were also using auto-scaling groups. For the database server, we decided to go with the R3 high memory Amazon EC2 template together with the IO1 provision IOPS. I'll talk more about why we choose the R3 high memory Amazon EC2 instances and the rationale behind choosing this particular instance in the upcoming slide. And also we chose to run the production server using on-demand instance model until we were confident in the configuration. After a few months, we chose to purchase the reserved instance type for the production and staging. As far as implementing HA and DR goes, Datavail, we recommended to use always-on availability groups, which comes with SQL Server 2014 Enterprise Edition, and we also recommended to take advantage of the availability zones in the AWS region. For the disaster recovery, we recommended to use a completely different environment in a separate AWS region. However, Sony challenged us in finding a more cost-effective approach for the DR. So the resulting design was to use a multi-AZ in a single region and use Amazon S3 and Amazon Glacier for storing SQL backups. We also decided to use auto-scaling groups, not for load balancing, but for automatically replacing the file node inside an always-on availability group. I'll talk about that more in the later slide. The outcome was, when we used the auto-scaling group, we were able to successfully replace the file node when the node went down. Reporting and replication. One of the biggest issues we had with reporting was we had to use the Blade server and FastLens for a replication subscriber. We also had a requirement to use a separate server or a separate VM for a replication distributor. And we also had 100 SQL Server reporting services subscriptions. The live application was also using the data on the reporting server. We were also dependent on some of the lead server objects for more or less real-time data. Some of the issues we ran into with the current architecture was whenever we had a bulk data fix or a table schema change, there was problem in replicating the data from the production server to the reporting server. And we had to take some outages, and also we had a big problem in terms of latency. So this really created complication in terms of accessing the reports, and also created complications in terms of accessing the more real-time data. So what we recommended was using SQL Server 2014 always-on availability groups, and also configure an active synchronous AAG between two nodes, and also a passive asynchronous AAG between other two nodes. I'll get into the details in the next slide. The results were we were able to get rid of the replication-related impacts, and we were able to get rid of the transaction replication architecture, and therefore no distributor was needed, and no separate subscriber was needed too. We were also able to configure read-only routing to process the reporting dashboard requests. What read-only routing means is we selectively route the queries, the read queries, to a different server. So our approach, the very big step we took in our approach was to do the performance baseline of the current server. And then we decided to use the multi-AZ capabilities and auto-scaling features in AWS. We also decided to upgrade the SQL Server from 2008 R2 to 2014 Enterprise Edition, and to use the always-on availability groups. We also decided to use Amazon S3 for backup storage and Amazon Glacier for long-term archival. We also used Amazon S3 for transferring backup files from on-prem to AWS. Like I said in my earlier slide, we were not able to use the Amazon database migration services because of the current network configuration in the on-prem environment. Performance baseline. Establishing a performance baseline for an on-prem server played a very critical role in choosing the right EC2 instance type in AWS. So as far as the performance baseline goes, we were mainly focused on memory, disk, CPU, and SQL statistics. I'm not going to get into the details of each performance counter under different sections, but however, collecting all this data related to these counters were very critical in establishing a baseline and also finding out like if there was any issue with memory, disk, or CPU in the current architecture. The methodology we used was we collected this SQL counters over the period of 4 days, and we calculated the minimum, maximum, and average value for each counter. And based on that, that helped us really choose the right instance type in terms of CPU, memory, and storage in AWS. Based on the performance baseline, we decided to go with R3.8x large instance type, which has 32 virtual CPUs and 24 GB of RAM. We decided not to go with the i2 instance type, which comes with an attached storage because it was more expensive than R3.8x large instance type. We also chose to choose the combination of general purpose and provision IOPS EBS volumes for the database storage. And as far as the ETL process goes, like I said earlier, we were able to get rid of the transaction replication, and we used the synchronous commit using the always-on availability groups. By synchronous commit, I mean the data is committed synchronously on 2 different nodes at the same time. We also configured read-only routing on top of AAG, which was used for data warehousing and reporting purposes. And as far as the HA goes, we configured an automatic failover between the primary replica and the synchronous secondary replica so that there is no data loss when one node goes down. We also used auto scaling to automatically replace the failed node. And as far as the cost optimization goes, we used reserved instances for the production and staging service. And we used on-demand instances for the testing dev so that we can stop them after the business hours. For the backup storage and archival process, we used S3 for storing 7 days of backups, and we used Amazon Glacier for storing backups that are month old. We also used the automatic lifecycle management in S3 to automatically archive the backup files. This is the schematic of the proposed architecture. As you can see, there are 3 different EC2 instances running Microsoft SQL Server 2014, running on 3 different AZs, AZ1, AZ2, and AZ3 inside an AWS region. You can also see the Windows failover cluster has been configured on top of all these 3 different nodes. And the primary reason for configuring Windows failover cluster is because Windows failover clustering is the prerequisite for configuring always-on availability groups. As you can see, there is a synchronous AAG configured between the primary replica in AZ1 and the secondary replica in AZ2. By synchronous commit, I mean the transactions are committed at the same time on both the nodes, so that there is no data loss when a failover occurs. You can also see there is an asynchronous AAG configured between primary replica on AZ1 and the secondary replica on AZ3. This asynchronous was used for DR purposes when needed. As I said before, we used auto scaling group between these 3 nodes to maintain the minimum number of nodes inside an AAG group. We had an occasion where one of the node went down, and the auto scaling group kicked in and automatically replaced the failed node. The S3 is also connected to the primary replica, where we take full backups and transaction log backups, and the S3, using automatic lifecycle management, we move the files out of S3 to Amazon Glacier. Talking about read-only routing. So read-only routing, what it means is we selectively route the read queries to a different node in the AAG. How that works is we have a client application that uses the group listener, which sits on top of the AAG. What the group listener does is it automatically routes the read queries to the secondary replica, which is very synchronous with the primary replica. And all the read-write queries, they go to the primary replica as usual. So in this way, we were able to load balance the queries, and also we were able to get rid of the transaction replication and change data capture. This seemed to work very well for the real-time dashboard application, which was done through SSRS. Post-migration activities. After we completed the migration and after we successfully started running the EC2 instances on AWS, we did a performance baseline using the same performance counters I talked about earlier. What we found was there was 30% improvement in the performance. We also started doing ongoing performance tuning in terms of query tuning, weight statistics analysis, and TemDB optimization. We're also doing database monitoring and alerting. We're using one of the Datavail's tool for monitoring the databases, and we're using the SQL Sentry for performance monitoring. We are also continuously doing index and statistics maintenance for better performance. We are also assisting Sony on database-related tasks during the sprint releases, and we are also maintaining the ongoing customer relationship. With that said, I'm going to open this up for questions and answers.
Thank you, Siva. I appreciate yours and Blaine's presentation. Certainly was very informative. So as Siva mentioned, we are now going to transition into the Q&A portion of this webinar. So if you haven't already done so, please feel free to submit your questions in the questions pane that's located in your control panel, and we'll address them during this portion of the meeting. And if for any reason we're unable to get to your question, then we will respond to each of those personally through email. So the first question I see here is, what is the best way to figure out if I should be on EC2 or RDS? That's an excellent question. Typically, we recommend that customers take a look at RDS first because it is a managed service offering, and as I mentioned previously, it takes a lot of the heavy lifting off of your shoulders. However, for some reason it doesn't meet your needs, then certainly SQL on EC2 is an excellent option as well, as Siva was able to explain during his portion of the presentation. So typically Amazon RDS is ideal for customers that are seeking to move to the cloud with the ease of a managed service, so that we can handle maintenance for you, handle the backups, the patching, as well as the configuration of the high availability. However, if it for some reason doesn't meet your needs, for example, your workload or you may require full administrative access to the database, then in that case, Amazon EC2 with SQL may be a better option. You can certainly find more information on the differences between RDS and EC2 when deploying Microsoft SQL Server on our white paper. We have one entitled Deploying SQL Server on AWS, so I encourage you to take a look at that as well for more details. Another question here is, how do I estimate my costs before moving to AWS? We do offer a simple monthly calculator to determine what your costs may potentially be on AWS. It's on our website, as well as a total cost of ownership calculator. So both are available on our website for you to take a look at, and it should help you estimate what your costs will be for whatever services you're going to run on AWS, and also help you determine how much you may potentially save by migrating those workloads to AWS versus running them in your own data center. Another question is, how would you approach uploading large sets of data from an on-premises data center to AWS? Well, we have several options for migrating your data to AWS, and definitely would recommend that you explore those options to determine which one would be best, because every situation is different, and one solution may be better over another depending on your circumstances. But just to give you a couple examples, two ways of transferring large data sets from your data center to AWS are using AWS Snowball, which is an appliance that we send to customers, we ship to you, and then you can transfer your data, terabytes of data, 50 terabytes or more, onto this appliance. and then have it shipped back to AWS where we import the data for you. So that's one quick way of doing it. Another is if you have Direct Connect, which is our high-speed direct connection between your data center and AWS, you can leverage our AWS import CLI tool or from the console to copy data over, and the service itself will actually leverage multi-part uploads, so it'll break up your data into chunks so that it uploads it as quickly as possible. But definitely for very large data sets, you may want to consider using the Snowball appliance. For databases, we do have, as was mentioned in this presentation, the database migration service that can help with migrating your databases to AWS. So another question here is, if I experience performance problems on RDS, how do I solve that? So we do provide you with visibility into how your RDS databases are performing. You can use performance monitoring tools like CloudWatch, as well as partner solutions to determine how it's performing, as well as the causes of any issues that you may be experiencing. Certainly, if you notice any constraints or bottlenecks with regards to processor performance, availability of RAM, disk performance, those are things that you can certainly address by perhaps selecting a larger instance type, or maybe going from generic IOPS to provisioned IOPS to ensure that you're receiving the required IOPS for your databases. So there's certainly actions that you can take. But if you're unsure on how to proceed, you can certainly reach out to our partner community, such as Datavail, to request assistance on any performance question, any RDS or any AWS-related service questions that you may have.
I also want to add to what Lou said in terms of troubleshooting the performance issues on RDS. We actually rely on the same DMVs for SQL servers that are running on EC2. We have access to all the DMVs on RDS, and then we can use them for analyzing some weight statistics. And also, you can correlate the data with some of the metrics that's in CloudWatch and try to troubleshoot the problem, performance problem. If there is a problem, the problem is related to locking and isolation, you probably have to follow the same strategy what you're doing in your SQL Server running on-prem or SQL Server running on EC2.
Very good. Thank you, Siva, for that.
I have a question here. Whether Sony DADC was ever open to moving away from Microsoft SQL Server to Aurora in consideration of licensing costs and things of that nature. That's definitely something that we've been able to look into. For our organization specifically, there would be a heavy development effort. One of the ways that we use Microsoft SQL Server is we have extensive application logic stored in stored procedures, and so a great deal of that would have to be modified or rewritten in order to handle another relational database system. So I think what we've kind of struck a balance between keeping the requirements of our Microsoft workloads in place and trying to find at the same time the most cost-effective way of moving those up to the cloud with AWS and with Datavail.
Again, as a reminder, if you have any questions that you'd like to ask, now would be the time. So please submit those questions in the question pane located in your control panel. Thank you.
I also have a question someone has asked. As I understand correctly, you use auto-scaling for SQL Server. Can you use some automation scripts to add new instance to Windows failover cluster? I think, Blaine, you probably have more details on the auto-scaling feature and how we are using it. I can probably talk a little bit on that. Yeah, we are using CloudFormation together with auto-scaling for replacing the fail node in the Windows cluster. Yes, we are using the scripts to automate the process, and it's been working pretty well. The only thing we need to do manually is to restore the databases and then to join those databases to AAG group.
We have a question there regarding how we back up RDS instances within AWS. So Amazon RDS creates and saves automated backups of your DB instance. RDS creates a storage volume snapshot of your DB instance, backing up the entire DB instance and not just the individual databases. So Amazon RDS creates automated backups of your DB instance during the backup window of your DB instance.
Okay. I also have a question. Have you used to bring your own licensing model? If so, how did you manage second SQL Server environment during the transition? So yes, we did the bring your own licensing model. Sony DADC NMS has an agreement with Microsoft and a service agreement with Microsoft. So we use that licensing model for running SQL Server on EC2 instances. There is a question about what did we do with the backups and that were taken prior to the migration, and what did we do with it? Actually, we were using the backup and restore strategy for synchronizing the data from on-prem to AWS. Like I said before, we were not able to use the database migration services to migrate the data. So what we did was we took a full backup and then we restored it on AWS, and then we took the transaction log backup before the final cutover, and then we restored that on AWS. In that we were able to sync the data for all the databases, and then we brought the databases online on AWS on the primary replica, and then we took a backup from the primary replica and put it on secondary replica for configuring the AAG. That's how we did it. Going back to the previous question, I see a follow-up question on that. How did we manage the bring your own licensing thing in two environments at the same time? Because we were running SQL Server 2008 R2 on the on-prem and SQL Server 2014 on AWS. So how do we manage that licensing thing at the same time? Hey, Blind, do you have any insights on how we manage the licensing for SQL Server running on two different environments? My take is I think the SQL Server we were running on EC2 on AWS is considered as a test instance or dev instance until it went live on production. That's my take. Correct me if I'm wrong.
That's correct. We've been using development licensing in lower environments. We have a software assurance agreement with Microsoft, so to some extent they are pretty lenient when it comes to doing, hot migrations and everything. So once we had our migration completed, then we just destroyed our old infrastructure when we left. So there hasn't been any, issue with that. But we just worked through our senior technology leadership and then their counterparts on the Microsoft side to make sure that everything remained above board as regards Microsoft licensing.
And that brings up a good point regarding test development environments. You could leverage your MSDN licenses on AWS as well. It would just require running on dedicated instances or dedicated hosts. But you can certainly take advantage of that investment, and it just needs to be a test dev type environment. And again, with software assurance and license mobility, you can run those products that have software assurance with license mobility in our default tenancy. Otherwise, you can bring your own licenses, but if they don't have software assurance, then you would run those in dedicated instances or dedicated host environment.
Okay.
Also, going back to a previous question regarding backing up RDS instances, I mentioned the built-in capabilities using snapshots to back up RDS. One important feature that was added, or support for an important feature within SQL that was added to RDS, was native full SQL Server backups. So that's another option if you wanted to perform a manual backup, you could perform a full backup and restore of SQL Server from on-prem or another SQL Server environment into RDS using native SQL Server backup. So just wanted to make everyone aware of that as well.
I also have a question on when you were creating your proposed architecture, you aligned with the baseline on the existing infrastructure. What challenges did you encounter there, and how did the workflow change once in the AWS ecosphere? So the answer is we did the performance baseline using different counters, and then we chose the instance type, which in our case is R2.8x large and EC2 based on the performance baseline. What we did was, once we chose the right instance type, we tried to simulate the load and do the testing, and we also ran the same performance baseline when we simulated the load before we went live. And we collected the same data for the period of 2 days, and we were trying to see if there was any values, for example, if the CPU and memory performance counters went beyond a threshold, or something we have to be concerned about. So we kind of analyzed that, and we built a confidence in terms of, okay, this instance type is going to work great for this workload. So we kind of got a good confidence in terms of like the EC2 instance type we chose, and that's how we proceeded with doing the load testing, and also if we were to accommodate any changes in terms of the instance type or storage or anything, we were going to do so, but we didn't have to at the time. So so thankfully everything worked out pretty good.
Great, thank you, Siva. So we're up at the hour here. We have less than a minute left, so just like to make a few closing remarks. We want to thank you all very much for attending. We also like to thank Siva and Blaine for their excellent presentation, very informative. And if you have any other questions, please don't hesitate to reach out directly. Thank you very much.